Okay, so today's notes are on factoring special cases or special quadratic instances, including the difference of two perfect squares and perfect square trinomials. Luckily, these can be done with the methods we've already talked about in class, but I'm hoping that we can learn to identify these so that we can save you some time and energy when you recognize that what these special cases are. So the first one we're going to start with is the difference of two perfect squares. And this one I think is the one people have a easier time identifying because it's a squared minus b squared. So you don't, instead of having a middle term, you just have two terms, and they both should be perfect squares. And when you factor them, they factor as a plus b, a minus b. So that's a subtraction in there if you can't see. So it factors to a plus b times a minus b. So we're going to do an example together. I want us to factor 25x squared minus 49. So step one, we have to recognize the two terms as perfect squares. So we recognize perfect squares. So I know 25 has a pretty square root of 5, x squared has a pretty square root of x, 49 has a pretty square root of 7, and when I say pretty, I mean it is an integer. So when we factor these, we're going to rewrite them square root, we're going to rewrite them as square roots squared. And what I mean by that is I take my 25x squared minus 49. I know that this is equal to 5x, that whole quantity squared, minus 7 squared. So I rewrote the square roots squared. And then I'm going to rewrite this in factored form. So now I know it's in this form, a squared minus b squared. So it's 5x squared minus 7 squared. So I can factor it to 5x plus 7 times 5x minus 7. So I just split it into the two perfect squares, so I write it in factored form. And voila, it's done. If we wanted to check our answer, as we've been practicing, we would redistribute and get 25x squared plus 35x minus 35x minus 49. And as we see, these two middle terms cancel out. So I'm left with 25x squared minus 49. So that checks out. As you might have noticed when we were checking our answer, what actually happens with our b terms is they cancel out. So you could also read our original expression as a normal quadratic without a b value. So if we're thinking of the form ax squared plus bx plus c, this is the same as that without a b value. So I'm going to make a little note of that. So we can note, if you do not remember how to factor two perfect squares, if you do not remember or recognize the difference of two perfect squares, you can still factor as if b were 0. So you can still factor normally as if b were 0. So if there is no coefficient of x, we just have a coefficient of x squared and a constant, there's no bx in the middle of our quadratic, then we know b is equal to 0, and then we can follow our normal factoring rules if you forget the rules for difference of two perfect squares. But easiest way would be to remember that you just have the difference of two perfect squares, so you set it into a plus b times a minus b. All right, so let's do a quick check together before we move on to our other one. So I want you to factor 16x squared minus 81. Go ahead and try that one on your own. I'm going to go over it now. So I know the square root of 16 is 4. The square root of x squared is x. So I know 4x squared minus 9 squared. So I recognize both those as perfect squares. and then I rewrite it as 4x plus 9 times 4x minus 9. And I'm all done. If we want to check our answer, we redistribute, the middle terms cancel, and we end up back where we started. I'm not going to show you that, but if you did that, great work. Okay, so the last one I'm going to do is even easier to treat like a normal rounding situation, but it's the perfect square trinomial. And I'm showing you this in hopes that you'll learn to recognize this on your own, but just like with our difference of two perfect squares, you can factor this just like all the other expressions we've been factoring. It just might save you some time and effort if you recognize that it is a perfect square trinomial. So a perfect square trinomial is the square of a binomial. So that means it would be something like a plus b squared. And when you distribute that out, you get a squared plus 2ab plus b squared. So if we recognize that we have two perfect squares on the end of our trinomials, and the middle term is 2 times their square roots, or 2 times a and b, those terms, then we can recognize it as a perfect square trinomial and skip some steps. Again, this is not super critical that you be able to do this in one step, but if you can recognize it, you can save yourself some time and energy. The example we're going to do together, I want us to factor x squared plus 10x plus 25, and I'm going to show you all the steps that you're working through in your head, but ultimately I want you to be able to jump from this to this without having to do all the middle steps. I'm just showing you what you could do in your head. So you recognize the first and last terms as perfect squares. So I know that x squared is a perfect square and 25 is a perfect square. And then I check to see if the middle term, this sounds complicated, but check if the middle term is twice the product of their square roots. And that sounds confusing. But in your head, you know x and 5. So if it's 2 times 5x, it's 10x. That is double their square roots. So I know it's a perfect square trinomial. And the more you practice this, the easier it'll get. So I know x squared is a perfect square. I know 25 is a perfect square. I know the square root of x squared is x. The square root of 25, or plus or minus x. The square root of 25 is plus or minus 5. I know 10, or 2 times 5x, or x times 5 is 10x, which matches my b term. So then I can just rewrite it as x plus 5, so x plus 5 squared. Again, you would want to pay attention to if there were negatives in here as well, because that might change whether you had a negative or a positive there. But since they're both positive, I'm working in positive, so it's just x plus 5 squared. So then I write, the last step is I write my binomial with the square root sign, or with the square roots. So I took my square roots, wrote my binomial, and squared it, and I was all done. So again, you can factor this with normal rounding rules. So a lot of you may have seen like 5 times 5 adds to 10. So I can do x plus 5 times x plus 5. But ultimately, I want you to write it as x plus 5 squared, or as a binomial squared, which is why I'm showing you this. And hopefully you can recognize that faster and faster as time goes on. So we're going to do a quick check together really fast. I want you to factor 64x squared minus 16x plus 1. Go ahead, try that on your own. I'm going to go over it now. So I recognize that the square root of 64x squared is going to be 8x, or plus or minus 8x. I recognize the square root of 1 is plus or minus 1. 2 times 8 times 1 is indeed 16, but since this is negative, I know I'm going to have a negative sign on one of these. So I could write it as either 8x minus 1 squared or negative 8x plus 1 squared. Both of those would end up working out. but I needed to make sure that they were negative so that I could get my negative b value in my expanded quadratic. So hopefully that will be helpful to you in the long run, but if this sounds more confusing than it's worth, keep factoring like normal. Make sure you write down any questions, comments, concerns so we can go over them together in class.